everybody, welcome to our 10.6 notes, coming to you from my house. For 10.6, you're going to be solving equations that contain radicals in them. So you're going to have equations that have square roots, or cube roots, or fourth roots, something like that in them. So let's talk about how to do that. So in general, your overall strategy is going to be raising them to some sort of a power to get rid of the root. So to get rid of the square root, you're going to be squaring. To get rid of a cube root, you're going to be cubing. To get rid of a fourth root, you'll be raising it to the fourth power, and so on. But we need to be pretty strategic about doing that. Because the thing is, if there's other stuff on the same side with it, and you square it, you don't just square the pieces, you square the whole thing. So really, when you're solving these, what you're going to want to do first is just get the radical by itself, so that when you square it, or cube it, or raise it to the fourth power, it actually does what you want it to do. Okay? So we'll make a little note here that you're going to want to isolate the radical first. Okay? So let's do a bunch of them. You ready? So example 1a, what I have is the square root of 5x plus 1 equals 4. Great news, our square root is already by itself. So that isolate the radical first thing, it's already by itself, which is awesome. So I'm ready to go. So to get rid of a square root, you do the opposite operation, which is squaring. So if I square both sides, what's going to happen is the squaring and the square rooting is going to cancel out, which is exciting. You'll just be left with 5x plus 1 on the left side. On the right side, we do need to square it, so 4 squared is 16. And then it's basic equation solving from there. I'll subtract 1 from both sides and get 5x equals 15, and divide both sides by 5, and x equals 3. Okay. It's always a good idea to check your work with these, just because, as you guys can tell, sometimes you get imaginary solutions that don't really work, so it's a good idea to check. So when I plug 3 back in, just doing a little check over to the side here, if I substitute 3 back in, let's see, 5 times 3 would be 15. We also have a plus 1. And I'm going to see, does that actually equal 4? Okay. 15 plus 1 would be 16. So I have the square root of 16 equals 4. Is that true? Yes, it is. So our solution checks out, and it is correct. Moving on to the next one. In 1b, I have the square root of 5x plus 3, then it has a plus 2 equals 0. So this one, our radical is not by itself yet, but it's pretty easy to get it by itself. I just need to get rid of that plus 2, and just like normal, we're going to do opposite operations. We're just going to subtract 2 to get it by itself. So then I'll have the square root of 5x plus 3 equals negative 2. And at this point, some sort of alarm bell should be going off in your brain and saying, wait a minute, I have a negative. Can a square root equal a negative number? No. No, it can't. So we can actually stop right then and don't do any more math because it's no solution. So no matter how hard I try, I'm not going to get a square root to equal a negative number. Alright, moving on here. We've got example 2 is the square root of 5 minus x equals x plus 1. This one's kind of fun because we have variables inside the radical and variables outside the radical, which makes things interesting for us. The good news is that my square root, it's already by itself, so there's nothing I need to do at the beginning, except just get started. So to get rid of the square root, I'm going to square both sides. And if you notice, I'm squaring the whole side, not just pieces and parts of it, as we're going to see here. So on the left side, the squaring and the square rooting undo each other. You're just left with 5 minus x. On the right side, I know it's really tempting to just square pieces and parts, but you've got to square the whole side, which actually means that what we're doing is x plus 1 squared, which is x plus 1 times x plus 1, and we're going to need to distribute that. Are you guys okay? So distributing, we'll have x times x, which is x squared. We'll have x times 1, which is 1x. We're going to have 1 times x, which is 1x. And 1 times 1, which is 1. Okay? At this point, I don't have any square roots, which is awesome. But I need to figure out how to solve my equation. It's not linear anymore, because I have an x squared. I definitely have a quadratic. So to solve a quadratic, just a quick little refresher. The only method you guys know at this point is solving by factoring. So I'm going to do a little quadratic refresher over here. Quadratic solving refresher. Okay, so solving by factoring, what you guys are going to do first is set the equation equal to 0. Okay, because then we can use what's called the zero factor property, which says if a couple of things multiply to equal 0, something has to be 0. And so then you make it into a multiplication so that you can use that, which you do by factoring. Okay? So set equal to 0 first, get everything on one side, and then you're going to factor it. Okay? And then we use the zero factor property and set each factor equal to 0 and solve. So we say, well, if a couple things multiply to equal 0, something has to be 0. And so we set each factor, which is going to look like your parentheses when you factor. So set each factor, which a lot of the times are in parentheses, equal to 0, and solve your little equations. Okay? Cat. Alright. This is my cat, by the way. He wants to help us with math. Alright, so now that we've done our little refresher, let's actually do it. Okay? So first thing is setting everything equal to 0. So for us, most of the stuff is on the left, so let's just keep it over there, okay? So I'm going to subtract 5 from both sides and add x to both sides just to get everything together. Okay? So then I will have a 0 on the left side. On the right side, I'll have an x squared. With the x's, I've got 1, 2, 3 x's, so plus 3x. And 1 minus 5 would be negative 4. Okay? So, step 1, complete. Okay? Now we're ready to factor it. This is a trinomial, so you should be doing guess and check factoring. So guess and check factoring, you start out with equal sets of parentheses, and it's like going backwards from FOILing something, okay? So you're thinking, what times what gives you x squared? Oh, there's really only one good choice for that, and that would be x times x. Then you're thinking for the last ones, what times what gives you a negative 4? Well, I can tell you for sure with it being negative, that one of them is going to be positive, and one's going to be negative, just to give me a negative number. And then I've got options. I can either do 4 and 1, or I can do 2 and 2. And that's when you start looking at the middle number, and I think, if I'm trying to get a 3, 2 and 2 is not going to get me there. It's probably going to be 4 and 1. So, let's try 4 and 1. And then you check, now that we've guessed. So the check that you do is the outer, which would be x times negative 1, so negative 1x, plus the inner, 4 times x, which would be 4x, should equal our middle number. So negative 1x plus 4x is 3x, which is our middle number, so we factor correctly. Okay? Now that we have factored it, so step 2 is done, we move on to step 3, which is set each factor equal to 0 and solve. So my factors are x plus 4 and x minus 1. So I'm going to start out with two little equations. I'm going to have x plus 4 equals 0. And then I'm also going to have x minus 1 equals 0. And then you solve your little equations, which aren't too bad. If x plus 4 equals 0, I'd subtract 4 from both sides, right? And so then I would have x equals negative 4. Or, on the other one, if I have x minus 1 equals 0, I would just add 1 to both sides. So x equals positive 1. Okay? And yet again, I should probably check my answers, okay? So let me box this off so I have some room to check. Okay, so checking both answers. So let's plug in negative 4 first and just see how that goes. So on the left side, I have the square root of 5 minus x. So 5 minus negative 4. So 5 minus negative 4. On the right side, I have x plus 1, so that would be negative 4 plus 1. And let's see how that works. So 5 minus negative 4, that's really 5 plus 4. I would have the square root of 9 on that side. And on the right side, I would have negative 4 plus 1. Negative 4 plus 1 is negative 3. So does the square root of 9 equal negative 3? Nope. It equals positive 3, not negative 3. Fortunately, x equals negative 4 doesn't work. Okay? Let's check 1 and make sure that 1 works okay. So for x equals 1, I'm going to have the square root of 5 minus x, so 5 minus 1. And I'm going to see, does that equal x plus 1? So 1 plus 1. Let's see if that works. Let's see, 5 minus 1 is 4. So I have square root of 4. And 1 plus 1 would be 2. Is the square root of 4 equal to 2? Yes. Yes, it is. So that one actually does work. So we only have one answer for this one. It's x equals 1. Just to let you guys know, you can have 2 answers. That's a possibility. You can have no answers. That's a possibility. So it just depends on the problem.